Take a good look at the stars tonight. Because the universe is expanding so fast, their light will soon never reach Earth again. Our sky is being erased. If gravity pulls everything together, why is the universe tearing itself apart faster than ever? You might think this endless sea of galaxies is eternal. I used to believe the cold, empty void was the scariest thing out there. But the terrifying truth is the void is not just empty space. It is an active predator hunting us. For thousands upon thousands of years, human beings have walked out into the cool night air, tilted their heads back and surrendered to the overwhelming majesty of the cosmos. We have stared into the glittering abyss and found comfort in its seemingly infinite expanse. We mapped the wandering stars, drew mythological heroes across the celestial sphere, and built entire civilizations under the assumption that the heavens above were a permanent, unchanging tapestry. We believed that the light reaching our eyes from distant constellations was a guaranteed promise, a connection to the rest of the cosmos that could never be severed. Even as our telescopes grew larger, evolving from simple glass lenses to towering observatories perched on mountain peaks, and eventually to orbiting satellites floating in the vacuum of space, our fundamental belief in a connected universe remained unshaken. We looked at the spiral arms of our Milky Way, a breathtaking metropolis of hundreds of billions of nuclear furnaces, and we felt anchored. We belonged to a galactic family, a gravitationally bound neighborhood known as the local group. Within this vast cosmic archipelago, our Milky Way is locked in a slow, elegant and billion-year-long gravitational dance with the Andromeda Galaxy, our massive and beautiful cosmic neighbor. Alongside us are the Triangulum Galaxy, and dozens of smaller irregular dwarf galaxies all swirling together through the dark ocean of deep space held tightly in a mutual embrace. According to everything we understood about the classical laws of physics, this localized gravitational tether is exactly how the entire universe should operate on every conceivable scale. We thought we had the grand narrative of existence completely figured out. The story began approximately 13.8 billion years ago, with the Big Bang, an event not merely of matter exploding into empty space, but of space itself erupting into existence. It was an event of unimaginable heat, pressure, and density, a violent unfurling of reality that sent the primordial soup of fundamental particles and radiant energy hurtling outward. It was the ultimate cosmic ignition, a phenomenal outward thrust that established the geometry and the expansion of the very fabric of space-time. But every explosion, no matter how profoundly energetic, must eventually contend with the fundamental forces left in its wake. And the undisputed king of the macroscopic universe, the architect of stars and the sculptor of galaxies, is gravity. Gravity is the universal glue, the invisible force that dictates the motion of planets, the birth of glowing nebulas, and the monumental structure of galaxy clusters. It is the ultimate manifestation of mass reaching out across the empty void to pull other mass toward it. Therefore, the logical, inescapable conclusion of 20th century astrophysics was that the universe was engaged in a monumental cosmic tug-of-war. On one side was the initial fading momentum of the Big Bang pushing the fabric of space apart. On the other side was the combined gravitational pull of every single atom, every solitary star, every monstrous supermassive black hole, and every massive galaxy in existence, desperately trying to pull everything back together. It was a colossal battle between outward expansion and inward attraction. And while the universe was undeniably still expanding, physicists were absolutely certain that this expansion had to be slowing down over time. It was considered basic cosmic common sense. If you throw a heavy stone up into the air, the kinetic energy from your arm pushes it upward, but the immense mass of the Earth inevitably slows its ascent, eventually stopping it completely and pulling it back down to the ground. The universe, we firmly believed, was that stone. We assumed we were living in a decelerating cosmos, a safe, predictable harbour where gravity would act as the eternal cosmic brake, exhausting the outward rush of creation across hundreds of billions of years. We intensely debated whether the universe would eventually halt and collapse back in on itself in a fiery apocalyptic big crunch, or if it would simply coast to a gentle, infinitely slow and peaceful halt. But the core assumption remained completely unquestioned throughout generations of scientific inquiry: gravity was in control. We thought we understood the fundamental machinery of reality. We thought mass and gravity ruled the dark. We were completely catastrophically wrong. The void was not empty. The void was waiting. And as we peered deeper into the darkness, expecting to find a universe gradually slowing its relentless pace, we instead stumbled upon a truth so deeply unsettling that it shattered the very foundation of modern cosmology and sealed the ultimate fate of everything we know. Einstein once called his cosmological constant the biggest blunder of his life. I thought his mistake was just a mathematical error, a footnote in the history of physics, but 100 years later, that exact mistake became the death sentence for the entire universe. To understand the magnitude of this impending catastrophe, we must journey back to the year 1915. Albert Einstein had just published his crowning achievement, the general theory of relativity. It was a masterpiece of human intellect, a sweeping mathematical framework that reimagined gravity not as an invisible tether pulling objects together, but as the fundamental curvature of space-time itself. Massive objects like stars and planets warped the fabric of the cosmos, dictating the paths of everything moving around them. However, when Einstein applied his beautiful, groundbreaking equations to the universe as a whole, he encountered a terrifying problem. The math insisted that the universe could not be static. The immense collective gravitational pull of all the matter within it meant the cosmos had to be dynamic. It either had to be expanding outward from an initial starting point, or contracting inward, collapsing upon itself under its own crushing weight. Einstein, deeply influenced by the prevailing philosophical and scientific beliefs of his time, found this idea deeply repulsive. He, like almost everyone else, desperately wanted a universe that was eternal, unchanging, and perfectly balanced. To force his equations to describe a static, immortal universe, he introduced a mathematical fudge factor, an arbitrary term he called the cosmological constant. He envisioned it as a mysterious, repulsive force inherent to space itself, perfectly tuned to counteract the inward pull of gravity. It was an elegant, if entirely theoretical, fix to save his philosophical worldview, but reality rarely conforms to human preference. Just over a decade later, the brilliant astronomer Edwin Hubble peered through the massive Hooker telescope in the mountains of California and shattered Einstein's static universe forever. Hubble discovered that distant galaxies were moving away from us, and the further away they were, the faster they were receding. The universe was undeniably, measurably expanding. Upon hearing this undeniable proof, Einstein reportedly abandoned his cosmological constant, entirely famously dismissing it as the greatest blunder of his scientific career. For decades, the concept was relegated to the dustbin of theoretical physics, an embarrassing error made by a genius trying to bend nature to his will. The expanding universe became scientific dogma, and the only question left was how quickly gravity would eventually pull the reins and slow it all down. Fast forward to the late 1990s, the expansion of the universe was a confirmed fact, but the ultimate question remained unanswered. Two fiercely competitive teams of brilliant astronomers, the Supernova Cosmology Project and the High Z Supernova Search Team, embarked on an ambitious, painstaking quest to measure this cosmic deceleration. Their tool of choice was one of the most violent and spectacular phenomena in nature, the Type 1 supernova. These are not ordinary dying stars. A Type 1. A supernova occurs in a binary star system where a dead, incredibly dense stellar remnant known as a white dwarf acts as a cosmic vampire. It slowly siphons volatile gas from its living companion star. As the white dwarf gorges on this stolen matter, its mass steadily increases until it hits a very specific, mathematically unbreakable threshold, known as the Chandrasekhar limit. precisely 1.4 times the mass of our Sun. The moment it crosses this line, the white dwarf cannot sustain its own immense weight. A catastrophic runaway nuclear fusion reaction ignites within a fraction of a second, completely obliterating the star in an explosion so fiercely luminous it can outshine an entire galaxy of 100 billion stars. Because they all explode at the exact same critical mass, every Type 1a supernova detonates with the exact same absolute intrinsic brightness. They are the ultimate cosmic lighthouses, standard candles that allow astronomers to measure unimaginable distances across the deep void. If you know exactly how bright the explosion truly is at its source, and you measure how dim it appears from Earth, you can calculate precisely how far the light has travelled through the expanding dark. The two teams spent years meticulously hunting for these fading embers across the deep void, pushing the absolute limits of technology to peer billions of light years into the deep past. By measuring the redshift of the galaxies hosting these supernovae, they could determine how much the universe had expanded while the light was in transit. They expected to find that the supernova were brighter and thus closer than they would be in a universe expanding at a constant steady rate. This would prove that gravity was successfully pulling the structure of the cosmos back together. But when the data was finally analysed, when the light from these ancient shattered stars was decoded, the results were not just confusing, they were utterly impossible. The supernovae were too dim, they were too far away. The light had taken longer to reach us than it should have. The researchers checked and rechecked their calculations, desperately looking for cosmic dust, obscuring the light or instrumental errors that could explain the anomaly. But the horrifying truth remained stubbornly fixed in the numbers. The expansion of the universe was not slowing down. It was speeding up. Galaxies were not just drifting apart on a fading cosmic breeze. They were being violently hurled away from one another at a rapidly accelerating exponential pace. Something invisible, something terrifyingly powerful was stepping on the cosmic gas pedal. It was a discovery so profoundly shocking that it won the researchers the Nobel Prize in Physics and simultaneously plunged astrophysics into a deep existential crisis. To make sense of this accelerating nightmare, physicists had to perform an act of scientific necromancy. They had to reach into the past and resurrect Albert Einstein's discarded blunder. The cosmological constant was back, but this time it was not a gentle stabilizing force keeping the universe static. It was an unstoppable dominant energy field driving the cosmos toward a terrifying, lonely demise. Because they had absolutely no idea what this repulsive force actually was, where it came from, or how it worked. They gave it a placeholder name, a title that reflects both the absolute depth of our scientific ignorance and the chilling nature of its overwhelming power. They called it dark energy. We spent centuries looking for physical monsters in the dark. I thought black holes were the ultimate destroyers, celestial leviathans that devour light and crush matter into isolated singularities. But the real monster is not hiding in the dark, it is the dark. When physicists finally crunched the complex numbers to figure out exactly what it would take to cause the catastrophic acceleration observed by the supernova teams, they arrived at a cosmic recipe that is profoundly humbling and deeply terrifying. Imagine taking the entire universe and putting it on a cosmic scale to see what it is actually made of. Everything that we consider to be reality, the towering pillars of creation in the Eagle Nebula, the blazing quasars at the edge of the observable universe, the Earth, the Sun, the Moon, and every single human being who has ever lived, makes up a pathetic 4.9% of the total mass and energy budget of the cosmos. We are practically a rounding error, a microscopic speck of dust on the cosmic stage. Another 26.8% belongs to dark matter, the invisible ghostly scaffolding that exerts gravitational pull and holds galaxies together. But the vast overwhelming majority of existence, a staggering 68.3%, is dark energy. To put it bluntly, humanity has spent its entire history studying less than 5% of reality, The universe is overwhelmingly dominated by a substance or a force or a property of space-time that we cannot see, cannot touch, cannot interact with, and fundamentally do not understand. It is omnipresent, filling every single cubic inch of the seemingly empty vacuum between the stars. But what exactly is it? The most prominent and widely accepted theory brings us back to the bizarre, counterintuitive realm of quantum mechanics. In classical physics, a vacuum is simply an empty box, a region of space entirely devoid of matter and radiation. But quantum mechanics tells us that true emptiness is an absolute illusion. On an infinitesimal subatomic scale, the vacuum of space is not a quiet, still ocean. It is a violently boiling cauldron of quantum fluctuations. According to the Heisenberg uncertainty principle, pairs of virtual particles and antiparticles are constantly popping into existence out of absolute nothingness, borrowing energy from the vacuum for a fleeting fraction of a second before annihilating each other and disappearing back into the void. This relentless, invisible bubbling creates an inherent underlying energy embedded within the fabric of space itself. This is what physicists refer to as vacuum energy. In theory, this vacuum energy should provide the exact repulsive push needed to explain dark energy and the accelerating expansion of the cosmos. But here is where astrophysics runs headfirst into a massive theoretical brick wall. When quantum physicists attempt to calculate exactly how much energy this boiling quantum vacuum should possess, they come up with a number that is unimaginably large. In fact, it is 120 orders of magnitude larger than the dark energy we actually observe pushing the galaxies apart. That is a one followed by 120 zeros. It is famously known as the worst theoretical prediction in the entire history of physics. If the quantum vacuum were actually as powerful as the mathematical models suggest, the repulsive force would have been so overwhelmingly violent that the universe would have ripped itself apart in the first microsecond after the Big Bang. Stars, galaxies, and life would never have had the chance to form, so the vacuum energy is simultaneously the best candidate we have for dark energy, and a mathematical nightmare that completely breaks our fundamental understanding of reality. We know it is there. We can see its horrifying effects on the galaxies, but the mechanics of its existence remain locked behind a veil of cosmic secrecy. Regardless of its true origin or its mathematical paradoxes, the most terrifying characteristic of dark energy is how it behaves as the universe expands. Normal matter and radiation behave in a way that makes logical sense to our human brains. If you have a sealed box filled with hot gas, and you artificially expand the size of the box, the gas inside spreads out, becoming less dense and much cooler. Its influence dilutes over a larger volume. For billions of years, as the universe expanded outward from the Big Bang, the density of matter and radiation steadily dropped. The universe cooled and thinned out, but dark energy is a fundamental property of space itself. It does not dilute. A cubic meter of empty space contains a specific, incredibly tiny amount of dark energy. When the universe expands and creates more physical space, it does not stretch the existing dark energy thinner. Instead, it creates more of it. Let that sink in for a moment. As space expands, more empty space comes into existence. Because there is more empty space, there is more dark energy. Because there is more dark energy, the repulsive force pushing the universe apart becomes exponentially stronger. Because the repulsive force is stronger, space expands even faster, creating even more space and consequently even more dark energy. It is an inescapable infinite feedback loop of cosmic destruction. For the first 9 billion years of cosmic history, the universe was small enough, and the matter within it was densely packed enough that gravity maintained the upper hand. The gravitational pull of the dark matter and regular matter acting as a unified team successfully slowed down the initial explosive expansion of the Big Bang, allowing colossal structures like galaxies, galaxy clusters, and superclusters to condense and thrive. It was an era of cosmic construction, but as the universe continued its slow, agonizing expansion, the matter within it became more and more diluted, spread out across vast stretching gulfs of newly created empty space. Gravity's grip began to weaken as the distances between galaxies grew, but the density of dark energy remained constant, biding its time in the shadows, silently growing in total volume as the universe swelled. About 5 billion years ago, roughly around the exact same time our own Sun and Earth were just beginning to form from a collapsing cloud of interstellar dust, a terrifying cosmic tipping point was reached. The total amount of dark energy in the expanding universe finally surpassed the collective gravitational pull of all the matter within it. Gravity lost its throne. The great cosmic braking mechanism failed completely. Dark energy seized absolute, uncontested control of the cosmos, throwing the expansion of the universe into an unrelenting, accelerating overdrive. We are no longer living in a universe governed by attraction and connection. We are trapped in a universe that is actively trying to tear itself apart piece by piece. I always thought the battle between light and dark was just a poetic metaphor. But right now, a literal violent war is raging across billions of light years and gravity is losing. To truly comprehend the sheer scale and the profound horror of this cosmic conflict, we have to understand the battlefield. The war between gravity and dark energy is fundamentally a war of distance. It is a terrifying tug of war where the rules change depending entirely on how far apart the combatants are standing. On a localized, intimate scale, gravity remains an absolute, uncontested tyrant. Within the borders of our own solar system, the immense, crushing mass of the Sun dictates the orbital mechanics of every planet, every asteroid and every comet with ruthless efficiency. The outward, repulsive push of dark energy exists here, quietly bubbling in the empty space between the Earth and Mars, but its influence is laughably weak compared to the overwhelming gravitational anchor of our star. We are perfectly safe from the stretching of space within our own celestial backyard. Even if we zoom out to the colossal scale of the entire Milky Way galaxy, gravity stands as an impenetrable fortress. The combined mass of hundreds of billions of stars, interstellar gas clouds, the monstrous supermassive black hole at the galactic center known as Sagittarius, a star, and the immense invisible halo of dark matter that surrounds us all, work together to create a gravitational bond that dark energy simply cannot break. Our galaxy is a unified, tightly bound structure that will easily survive the expansion of the wider universe. We can zoom out even further, stepping beyond the borders of the Milky Way to look at our immediate cosmic neighborhood, the local group. Here, gravity is still preparing for its grandest, most spectacular victory. The Andromeda Galaxy, a spiral behemoth significantly larger than our own, is currently hurtling toward us at a staggering speed of 250,000 miles per hour. Despite the relentless expansion of the space separating us, the mutual gravitational attraction between the Milky Way and Andromeda is simply too powerful. Dark energy is pushing, but gravity is pulling much, much harder. In about 4.5 billion years, these two magnificent island universes will collide in an agonizingly slow, breathtakingly beautiful cosmic dance, eventually merging to form a single, monumental elliptical supergalaxy. This colossal merger represents the absolute zenith of gravity's power. It is the final, greatest structure that gravity will ever be allowed to build in our corner of the cosmos. Because once we look past the local group, once we cast our gaze across the truly macroscopic architecture of the universe, the terrifying reality of dark energy's dominance becomes undeniable. Beyond our local neighborhood lies a mind-bending structure known as the cosmic web. If you could step outside the universe and observe it in its entirety, it would not look like a random scattering of stars. It looks exactly like a colossal glowing neural network. Vast glowing filaments of dark matter and thousands of galaxies stretch across millions of light years, intersecting at unimaginably dense nodes called galaxy clusters. Between these glowing filaments are the cosmic void's monumental expanses of utter nothingness that span hundreds of millions of light years across. It is here in the cold, desolate emptiness of the macroscopic voids that dark energy executes its terrifying strategy. Because dark energy is a property of empty space, the larger the void, the more dark energy it contains and the stronger its repulsive outward push becomes. The voids are swelling. They are acting like macroscopic balloons inflating within the cosmic web, violently pushing against the fragile filaments of galaxies that surround them. For decades, astronomers mapped out colossal structures like the Virgo supercluster and the magnificent Laniakea supercluster, a staggering congregation of 100,000 galaxies, including our own, spanning 520 million light-years. We proudly drew maps of these superclusters, believing them to be the largest gravitationally bound structures in reality, monumental cities of light connected by the unbreakable bonds of dark matter. But the horrifying truth recently uncovered by the precise measurement of dark energy is that these superclusters are not bound structures at all. They are illusions. They are temporary fading phantoms of a younger, denser universe. The gravitational tethers connecting the distinct galaxy clusters within Laniakea are failing. The terrifying accelerating expansion of the voids is simply too fast. Dark energy is driving a wedge of rapidly multiplying empty space between these massive structures. Slowly, but with absolute mathematical certainty, the magnificent cosmic web is being dismantled. The glowing filaments are being stretched, severed, and pushed apart. The grand architecture of the universe is unraveling before our very eyes. We are not living in a cohesive, connected cosmos. We are living in a universe that is being violently sliced into isolated, disconnected islands. And as dark energy continues to multiply, accelerating the expansion to unimaginable speeds, the chilling consequence of this macroscopic war of attrition becomes terrifyingly clear. Gravity will secure its local territories, binding the Milky Way and Andromeda together, but it will lose the rest of reality. We are about to be cut off from the universe forever. You probably fear the idea of being alone in the dark. I thought human loneliness was profound, but soon our entire Milky Way will be locked in an inescapable cosmic solitary confinement. To understand the sheer terror of this impending isolation, we must introduce a concept that is every bit as horrifying as a black hole, but on a scale that encompasses the entire universe. The cosmic event horizon. When we think of an event horizon, we usually picture the pitch-black sphere surrounding a singularity, the point of no return where gravity is so intense that not even light can escape its inward pull. The cosmic event horizon is the exact same principle, but terrifyingly inverted. Instead of being pulled into a singularity, the universe is pulling away from us. Because dark energy is causing the expansion of space to accelerate the further away an object is. From the Earth, the faster it appears to be receding. Eventually, at a certain distance, the expansion of space between us and a distant galaxy becomes so rapid that the distance is increasing faster than the speed of light itself. It is crucial to understand that this does not violate Einstein's theory of relativity. Einstein dictated that no physical object can move through the fabric of space faster than the speed of light. But dark energy is not moving galaxies through space. It is injecting new space between them. The fabric of reality itself is stretching, and there is absolutely no speed limit on how fast space can expand. Imagine drawing two dots on a deflated balloon, and then inflating it as fast as you can. The dots themselves are not moving across the rubber, but the rubber between them is expanding, driving them apart. Right now, the cosmic event horizon surrounding our observable universe is located roughly 16 billion light-years away. Any galaxy situated beyond that invisible boundary is functionally lost to us forever. If a star explodes in a supernova beyond that line today, its light will travel toward us at 186,000 miles per second. But the space between us and that photon of light will expand faster than the light can traverse it. It is like a person trying to run up a down escalator that is accelerating. They will never ever reach the top. This is the horrifying reality of our cosmic era. The galaxies we capture in the breathtaking deep field images of the James Webb Space Telescope, those glittering jewels scattered across the dawn of time, are already gone. The light we are seeing today was emitted billions of years ago. In the present moment, the vast majority of those distant galaxies have already crossed the cosmic event horizon. They have been swept away by the unstoppable tide of dark energy. We are simply looking at their ghosts. But what happens to the galaxies that are closer to us, the ones that have not yet crossed the threshold, over the next 100 billion years as the expansion of the universe continues to accelerate exponentially? The cosmic event horizon will rapidly shrink around us. It is a tightening noose of absolute nothingness. One by one, the galaxies in our supercluster will cross the line. We will not see them suddenly vanish. It is not like flipping off a light switch. Instead, they will undergo a slow, agonizing death by redshift. As the space between us and the departing galaxy stretches, the wavelengths of the light it emits are stretched along with it. The light will shift from vibrant blue to deep red, then stretch further into invisible infrared, then down into microwaves, and finally into the ultra-low frequencies of radio waves. To the eyes of any future astronomers, the galaxy will simply grow dimmer and colder and fainter, until it quietly fades into the absolute blackness of the void. It is a cosmic vanishing act playing out in agonizingly slow motion. But dark energy will not stop at erasing our galactic neighbours. It is going to erase the very history of our creation. When the universe was born in the Big Bang, it left behind a faint glowing echo of radiation known as the cosmic microwave background, or the CMB. It is a bath of ancient light that permeates every single direction of the sky. The ultimate proof that the universe was once a hot, infinitely dense point. But this ancient light is also subject to the stretching of space. As the universe accelerates outward, the wavelengths of the CMB will be stretched thinner and thinner. Eventually, the wavelength of this foundational light will become longer than the physical diameter of our entire observable universe. It will become completely undetectable by any conceivable technology. The birth certificate of the universe will be systematically shredded and thrown into the void. This leaves our home, the Milky Way, in a terrifying predicament. As we establish gravity will win the local war. We will merge with Andromeda and our local dwarf galaxies to form a massive singular supergalaxy known as Milkomeda. But beyond the borders of Milkomeda there will be absolutely nothing. The cosmic event horizon will close in until it wraps tightly around our newly formed supergalaxy. We will be a lone fortress, a solitary island of aging stars adrift in an infinite, violently expanding ocean of utter darkness. The era of a connected, populated universe will officially end. The era of isolation will begin, and it will be an imprisonment that will last until the very end of time itself. Imagine a civilization born 100 billion years from now. I thought they would have godlike technology to explore the cosmos. But the tragedy is they will not even know the rest of the universe exists. By that time, the cosmic event horizon will have shrunk so drastically that their observable universe will be identical to the borders of the Milkomeda supergalaxy. The brilliant spiral arms that once defined the Milky Way and Andromeda will be entirely gone, consumed in the chaotic merger. The sky will be dominated by an aging elliptical swarm of red dwarf stars burning slowly and dimly in the final epochs of stellar evolution. But the most horrifying change will be the absolute absence of context. When the astronomers of this distant future civilization point their most powerful telescopes out into the deep void, searching for answers, they will see absolutely nothing. The cosmic web, the superclusters, the billions of distant galaxies that once painted the night sky will all have crossed the cosmic event horizon. They will have been pushed away faster than the speed of light, their photons stretched into undetectable oblivion. There will be no background radiation to whisper the story of the Big Bang. There will be no expanding space to measure. Their universe will appear completely static, eternal, and utterly alone. If they develop their own rigorous scientific methods, if they build observatories and derive the laws of physics from what they can observe, they will naturally conclude that their single supergalaxy is the entirety of existence. They will believe that they are the only island in an infinite empty sea, All the knowledge we are gathering right now, the rich, magnificent history of the cosmos, the violent birth of the universe, and the cosmic tug-of-war between gravity and dark energy, will be completely wiped from the record. The universe is actively destroying its own history. We are living in an incredibly privileged era, a fleeting golden window of time where the cosmos is still young enough to reveal its majestic structure, yet old enough to have bred conscious observers capable of understanding it. We always assumed the universe would just quietly freeze to death over trillions of years. I thought a slow icy demise was the only path, but dark energy might have a much more violent, gruesome end in mind. The scenario we just explored, where galaxies drift apart but stay intact, is known among cosmologists as the Big Freeze or the Heat Death. In this future, the universe expands infinitely. Stars slowly exhaust their nuclear fuel, and matter eventually decays into a soup of cold, disconnected photons. It is a profoundly depressing but fundamentally peaceful death. A slow fade to black over unimaginable eons. But theoretical physicists are haunted by another far more terrifying possibility. This nightmare scenario hinges entirely on the precise nature of dark energy, specifically its equation of state. What if dark energy is not just a constant, unchanging property of empty space? What if its repulsive power is actually increasing over time? This hypothetical form of acceleration is called phantom energy. If phantom energy exists, the expansion of the universe will not just push galaxies apart at a steady accelerating rate, it will accelerate so violently, so exponentially, that the very fabric of space and time will be subjected to an infinite tearing force. This catastrophic climax, the absolute destruction of reality, is known as the Big Rip. In this scenario, gravity does not just lose the cosmic tug-of-war on a macro scale, it loses on every conceivable scale right down to the quantum level. The invisible force pushing the universe apart will eventually overpower the electromagnetic force holding molecules together, and finally the strong nuclear force that binds the core of atoms. It will not be a slow, quiet fade into the dark. It will be a violent, screaming disintegration of everything that physically exists. I thought the destruction of Earth by our dying sun was the ultimate apocalypse. But a Big Rip would not just burn us. It would tear apart the very fabric of reality right down to the atoms in your blood. If the phantom energy hypothesis proves to be correct, the death of the universe will not be a peaceful transition into a cold sleep. It will be an execution. To truly grasp the unfathomable horror of the Big Rip, we must walk through its theoretical timeline, a morbid countdown to the absolute end of physics. This will not happen tomorrow, nor will it happen a billion years from now. This is a catastrophe reserved for the deep, unfathomable future when the density of phantom energy reaches a critical, infinite threshold. If this nightmare scenario unfolds, the tearing of the universe will not happen all at once. It will be a progressive, relentless, and terrifyingly systematic dismantling of scale, working its way down from the macroscopic titans of the cosmos to the microscopic building blocks of life. Let us set the cosmic clock to the final chapter of existence and begin the countdown. 60 million years before the end. Up until this point, the supergalaxy of Milkomeda has been a safe haven, a gravitationally bound fortress surviving the isolation of the void. But the phantom energy has grown too powerful. The repulsive force of empty space finally overwhelms the combined gravitational mass of hundreds of billions of stars and the central supermassive black hole. The galactic fortress is breached. The outer stars are the first to be stripped away, pulled out of their orbital paths and scattered into the infinite darkness like glowing dust in a violent hurricane. Over the course of millions of years, the great supergalaxy is methodically disassembled. The night sky, which future observers once thought was an eternal, unchanging cluster of local stars, rapidly empties out. The gravitational tethers are severed, and every single star is violently thrown into solitary confinement. Our solar system, or whatever remains of it in this deep future, is sent hurtling alone into the freezing, accelerating abyss. 3 months before the end, The phantom energy has now trickled down to the scale of individual stellar systems. For billions of years, the planets have faithfully orbited their host stars, bound by the familiar comforting laws of Newtonian gravity. But that celestial machinery is now broken. The repulsive push of space itself becomes stronger than the gravitational pull of the central star. The planets are violently ripped from their orbits. If Earth or any surviving planet is still intact, it will be suddenly and violently disconnected from its sun. It will spiral outward, plunged into absolute freezing darkness. The solar system, a structure that survived the violent birth of the universe, and the chaotic merger of galaxies, simply dissolves. The planets are cast out as rogue worlds accelerating away from each other at terrifying speeds, completely blind and entirely alone. 30 minutes before the end, the horror descends from the celestial to the planetary. The phantom energy is now so dense, so overwhelmingly powerful, that it attacks the structural integrity of solid matter. The gravitational forces holding planets and moons together are suddenly neutralized. For a planet like Earth, this is the moment of physical disintegration. Without gravity pulling its mass inward toward the core, the immense internal pressures of the planet have nothing holding them back. The crust will violently fracture, unleashing a planetary network of apocalyptic earthquakes. The oceans will boil into space as the atmosphere is instantly stripped away. Within minutes, the entire planet will shatter, exploding outward into billions of fragments of rock iron and magma. The Earth is dead, reduced to a rapidly expanding cloud of debris. Fractions of a second before the end, we have reached the microscopic realm. The macroscopic universe is entirely gone, but the phantom energy is not finished. It now attacks the fundamental forces of nature. The electromagnetic force, the invisible glue that binds molecules and chemistry together, is completely overpowered. Every solid object, every liquid, every gas is ripped apart into individual atoms. If a human being were somehow alive to witness this, they would not suffocate or freeze. The complex molecules of their DNA, the water in their cells, the iron in their blood would violently separate. Biology ceases to exist. Chemistry ceases to exist. The final microscopic fraction of a second, the absolute end, the phantom energy breaches the nucleus of the atom. The strong nuclear force, the most powerful and impenetrable bond in the universe, the force that holds protons and neutrons together, is shattered. The atomic cores are torn open, bleeding subatomic quarks into the void. And then in the final unmeasurable instant, the fabric of space-time itself can no longer stretch. It reaches its absolute breaking point and simply tears. The universe ends in a localized singularity of infinite expansion. There is no more space. There is no more time. There is only an incomprehensible fragmented void where the laws of physics have been permanently erased. Reality itself is executed. Humanity always looks for a loophole, a way to survive the impossible. I thought advanced civilizations could build arcs to escape. But how do you escape when space itself is the weapon? Whenever we are faced with an apocalyptic scenario, our natural instinct is to engineer a solution. If an asteroid threatens Earth, we calculate how to deflect it. If our sun begins to expand into a red giant, we theorize about moving our planet's orbit, or migrating to the outer moons of Jupiter and Saturn. We rely on the Kardashev scale, a theoretical framework measuring a civilization's technological advancement based on its energy consumption. We imagine that Type 3 civilization beings capable of harnessing the energy output of an entire galaxy would essentially become gods. They would construct Dyson spheres around millions of stars, harvest the rotational energy of black holes, and bend the local environment of the cosmos to their will. We assume that with enough time, intelligence, and resources, any physical threat can be mitigated, contained, or outrun. But dark energy completely shatters this arrogant assumption. It is fundamentally different from any localized astrophysical hazard. It is not a rogue star. It is not a burst of deadly gamma radiation. And it is not a supermassive black hole consuming its neighbors. Dark energy is the fabric of reality turning against us. How do you build a wall to keep out the void when the void is expanding inside the wall, inside the bricks and inside the atoms that make up the bricks. Faced with the absolute annihilation of a big rip or the eternal freezing isolation of a big freeze, theoretical physicists have stretched the absolute limits of mathematics to find a survival mechanism for hypothetical ultra-advanced beings. The first desperate concept is the creation of a pocket universe, a localized bubble of space-time artificially engineered to resist the expansion of the wider cosmos. To achieve this, a civilization would need to master the manipulation of exotic matter, a theoretical substance possessing negative mass. By carefully arranging vast quantities of exotic matter, they might create a gravitational shield, a closed metric of space-time where the repulsive push of dark energy is perfectly counterbalanced by an engineered inward pull. They would become castaways locking themselves inside a microscopic artificially sustained bubble, while the rest of reality is violently shredded around them. But the energy requirements to create and maintain such a structure would be incomprehensible, and the physics of exotic matter remain entirely speculative. There is a high probability that such a pocket universe would be inherently unstable, violently collapsing in on itself the moment the surrounding universe tears apart. If you cannot build a bunker to survive the end of space, the only remaining option is evacuation. This brings us to the ultimate final frontier of survival cosmology, the multiverse. According to the theory of eternal inflation, our universe is not the only one. It is merely one expanding bubble in an infinite boiling ocean of cosmic foam. While our specific bubble universe is dying corrupted by an overdose of dark energy, other universes are constantly being born, each with their own unique laws of physics. If a dying Type 3 civilization realizes that their home is irreparably doomed, their final monumental project would not be a spaceship but a reality ship. They would attempt to tear a hole in the fabric of their dying universe, constructing a traversable wormhole, an Einstein-Rosen bridge connecting our collapsing reality to a younger, safer bubble universe. The tragic, bitter irony of this survival plan is that keeping a wormhole open and stable requires an immense infusion of the exact same negative energy that is currently tearing our universe apart. To escape the monster, they must learn to perfectly control it. It is the ultimate Hail Mary pass of a desperate dying civilization. But if the mathematics of the multiverse are wrong, or if the energy barrier between realities is too high, then this final door remains permanently locked. There is no escape for any consciousness trapped within the boundaries of our cosmos. The end is absolute, final, and inescapable. The universe began with a deafening bang forged in unimaginable fire. I thought its final breath would be a spectacular explosion, but instead it will end in absolute terrifying silence. After the violent screaming climax of the Big Rip, or trillions of years deep into the dark freezing decay of the heat death, the great cosmic drama will finally conclude. The stage upon which the magnificent story of stars, galaxies, and life played out will be entirely empty. There will be no light to illuminate the dark because there will be no stars left to shine, and no photons left with enough energy to be perceived. There will be no warmth as the temperature of the void approaches absolute zero, the point where all atomic motion completely ceases. There will be no structures, no planets, no black holes, no atoms, and eventually no fundamental particles. The universe will reach a state of maximum entropy, a state of perfect unchanging equilibrium, because nothing will ever happen again. Time itself will effectively lose all meaning. A clock measures the passage of events, but in a universe where nothing moves, nothing changes, and nothing interacts, time becomes a redundant concept. The great silence will descend upon reality, an eternal undisturbed peace that will reign supreme forever. But as we pull back from this horrifying, unfathomable glimpse into the infinite future, as we return from the absolute edge of time, we must anchor ourselves firmly in the present moment. The story of dark energy is a narrative of profound loss and terrifying isolation, but it is also a story that highlights an incredibly beautiful truth. We exist right now. We are living in the stelliferous era, the golden age, the absolute prime of the cosmos. Look up at the sky tonight. The stars are burning brightly, casting their ancient light across the void. Galaxies are swirling in majestic, chaotic dances, forming structures of unimaginable beauty. The universe is currently operating in a perfect, delicate balance, a fleeting Goldilocks zone of cosmic history. It has cooled enough since the violent fires of the Big Bang to allow complex chemistry and biology to flourish, yet it has not expanded enough to cast us into the cold, isolated dark. We are not merely inhabitants of this universe, we are the universe itself. We are hydrogen, carbon and stardust arranged in a pattern so miraculously complex that it woke up. We are the cosmos experiencing its own majesty, conscious of our own fleeting existence, and capable of comprehending our impending doom. The knowledge of the great silence should not paralyze us with existential dread. Instead, it should fill us with a profound, overwhelming sense of gratitude. Every sunset you witness, every starry night you observe, every moment of human connection you experience is infinitely valuable, precisely because it is temporary. It is a brilliant spark of light and warmth in a universe destined for cold, silent oblivion. Do not fear the darkness that is waiting at the end of time. Instead, marvel fiercely at the light while it is still here to guide us. We are the lucky few, the fleeting observers who get to witness the universe in its most magnificent, fragile glory. We have faced the ultimate end brought by dark energy today, but next part we will uncover a far more terrifying anomaly, hiding inside supermassive black holes, something so unnatural that even dark energy cannot destroy it. You absolutely do not want to miss this truth. Hit that subscribe button now and prepare yourself. We always thought the end of the universe was a time in the distant future. But what if the end of space and time is not a when, but a where? And what if millions of these apocalyptic destinations are hiding right now in our very own universe? We look up at the night sky and see a canvas of infinite possibilities, a sprawling theatre of light and motion. We measure the cosmos in billions of years, charting the slow, agonizing death of stars and the relentless, accelerating expansion of the void driven by dark energy. We project our fears of the apocalypse into a timeline, an inevitable heat death, or a catastrophic tearing of reality that awaits our descendants countless eons from today. We comfort ourselves with the sheer distance of this doom, but this comfort is a profound illusion. The end of reality, the absolute collapse of the laws of physics, the boundary where mathematics shatters and the universe simply gives up, is not waiting for us at the end of time. It is a physical location. It is a destination you could theoretically travel to right now. And the most terrifying part is that we are surrounded by them. They are the darkest, most violent and most incomprehensible objects ever hypothesized by human minds. They are black holes. And in this journey, we are not just going to observe them from a safe distance. We are going to cross the boundary of no return. We are going to dive into the abyss, experience the physical and psychological horror of the descent, and witness the ultimate breakdown of nature at the singularity, the exact coordinate where God divided by zero. I used to think black holes were just mindless vacuums sucking up the universe. But the terrifying truth is they are the very architects that built our galaxies. For the longest time, science fiction and popular culture have painted a deeply misleading portrait of black holes. We have been taught to imagine them as cosmic vacuum cleaners, wandering rogue through the interstellar dark, indiscriminately inhaling planets, stars, and any unfortunate matter that happens to drift too close. We viewed them purely as engines of destruction, localized pockets of doom. But as our telescopes grew more powerful, allowing us to pierce the dense, obscuring veils of cosmic dust that shroud the deep centers of galaxies, astronomers discovered a truth that was far more majestic and infinitely more terrifying. At the very heart of the Milky Way, buried 26,000 light-years away from the safety of our solar system, lies a monster. It is a region of space known as Sagittarius, a star. For decades, astronomers tracked the movements of stars near the galactic center. They watched in absolute awe and creeping dread as massive blue giant stars, dozens of times larger than our own sun, whipped around an invisible point in space at staggering impossible speeds. Some of these stars were moving at millions of miles per hour, slingshotting around a patch of absolute blackness. The sheer gravitational force required to hold these massive stars in such tight, chaotic orbits without letting them fly off into the void was incomprehensible. When physicists crunched the numbers calculating the mass required to generate that invisible crushing tether, the result was staggering. Hiding in that tiny invisible point was a mass equivalent to 4,300,000 of our suns crushed down into a space smaller than the orbit of Mercury. It was the undeniable signature of a supermassive black hole. But the revelation did not stop with the Milky Way. As we pointed our instruments at the Andromeda Galaxy, the Sombrero Galaxy, and thousands of other island universes scattered across the deep field of the cosmos, we found the exact same terrifying signature. A supermassive black hole sits at the core of virtually every single large galaxy in the observable universe. This changes everything. It completely rewrites our understanding of cosmic evolution. These titans of gravity are not just random accidents or isolated cosmic hazards. They are the fundamental anchors of reality. Without the immense stabilizing gravitational well of Sagittarius, a star, the Milky Way as we know it would not exist. The delicate spiraling arms of stars, the vast nebular nurseries where new worlds are born, and the very stability of our own solar system are all ultimately tethered to the gravitational authority of this central leviathan. It is a profound mind-bending paradox. The most destructive, unforgiving force in nature, an object that literally rips space and time to shreds, is the exact same force that gathered the primordial gas and dust together to form the galaxy that gave us life. We are born from the chaotic, violent accretion of matter swirling around a cosmic drain. We owe our very existence to the monster in the dark. How did these monsters get there? This is one of the most agonizing, unresolved mysteries in modern astrophysics. We know how stellar mass black holes form. When a massive star, perhaps 20 or 30 times the weight of our Sun, exhausts its nuclear fuel, the outward pressure of fusion violently ceases. In a fraction of a second, the core collapses under its own immense gravity. The star detonates in a magnificent supernova, while the core is crushed down into a singularity, a point of infinite density. This creates a black hole a few dozen times heavier than our Sun, but you cannot simply merge enough of these small black holes together to create a supermassive titan of 4 million solar masses within the time frame of the early universe. There simply has not been enough time since the Big Bang for a black hole to eat that much matter one star at a time. This terrifying realization implies a catastrophic alternative. In the cosmic dawn, shortly after the universe cooled from the fires of creation, monumental clouds of pristine hydrogen gas, millions of times heavier than our Sun, may have collapsed directly inward. Instead of fracturing into thousands of individual stars, the entire cloud caved in on itself under crushing apocalyptic gravity, bypassing the star phase entirely to form a massive seed black hole. These primordial titans were born hungry, violently swallowing surrounding gas and merging with other seeds to quickly build the galactic empires we see today. They are not the remnants of dead stars. They are the dark seeds of the universe itself, planted in the primordial void to grow galaxies around them. They are the silent, sleeping gods of the cosmos, holding billions of stars in their grasp. And while our god is currently quiet, others are screaming into the void. You might think our galaxy's supermassive black hole is terrifying. I thought 4 million solar masses was the absolute limit. But out there in the deep dark, there are leviathans that make our monster look like a grain of sand. We human beings struggle to comprehend true cosmic scale. Our brains evolved to understand the distance to the next watering hole, the height of a mountain, or perhaps the span of a continent. When we try to visualize the Earth, a sphere 8,000 miles wide, our imagination begins to stretch. When we think of the Sun, a raging nuclear furnace 1 million times the volume of our planet, our comprehension fractures, And when we consider Sagittarius a star, the 4 million solar mass black hole anchoring the Milky Way, we surrender entirely to the abstraction of mathematics. We console ourselves by believing that this is the apex of gravity, the ultimate ceiling of nature's destructive capacity. We assume that 4 million suns crushed into a singularity is as extreme as the universe can possibly get. But the universe does not care about the limits of human imagination. As we gaze deeper into the cosmos past our local group of galaxies, past the sprawling superclusters, and into the unimaginably distant reaches of the observable universe, we've discovered things that break the scale completely. We have found the cosmic leviathans. Consider a quasar known as TON 618. Located over 10 billion light-years away, it shines with the blinding brilliance of 140 trillion suns. It is one of the most luminous objects ever observed in the history of astronomy. But that light is not coming from the black hole itself. It is coming from the superheated disk of agonizing matter swirling around it, frictionally heating up as it prepares to be swallowed. To generate that much light, the black hole actively feeding at the center of TON 618 must be possessing a mass that defies all logical reason. When astronomers calculated its weight, the result was so absurd it sounded like a typographical error. TON 618 does not weigh 4 million solar masses. It weighs an estimated 66 billion solar masses. Let that sink into your consciousness. 66 billion suns crushed into a single point in space. It is a mass greater than all the stars in the Milky Way galaxy combined, trapped inside a single solitary object. To truly understand the horror of TON 618, we must look at its physical size, specifically the diameter of its event horizon, the absolute boundary of no return. For Sagittarius, a star, the event horizon is roughly 26 million kilometers across, easily fitting within the orbit of Mercury. If you replaced our Sun with TON 618, the result would be an apocalyptic erasure of our entire solar system and everything far beyond it. The radius of its event horizon is estimated to be roughly 390 billion kilometers. To put that into perspective, Neptune, the outermost major planet in our solar system, orbits the Sun at a distance of about 4.5 billion kilometers. The Voyager 1 spacecraft, which launched in 1977 and has been traveling at over 38,000 miles per hour for nearly half a century, has barely crossed 24 billion kilometers into interstellar space. The darkness of TON 618 would swallow the Sun, swallow the Earth, swallow Neptune, swallow Voyager 1, and continue outward for hundreds of billions of miles into the interstellar void. It is a sphere of absolute inescapable nothingness, so unfathomably massive that it would take a beam of light travelling at 186,000 miles per second more than a month just to cross from one side of the shadow to the other. But the nightmare does not end there. Just when physicists thought they had found the absolute upper limit of how large a black hole could grow before the physics of the accretion disk simply starved it of fuel, they discovered the Phoenix cluster. Buried at the centre of this colossal galaxy cluster reigning over trillions of stars is an entity known as Phoenix a star. It belongs to an entirely new, terrifying theoretical classification. Astronomers call them slabs or stupendously large black holes. Phoenix a star dwarfs even TON 618. Current estimates place its mass at a staggering 100 billion solar masses. It is so incomprehensibly massive that it cannot be explained by any standard model of black hole growth. It could not have formed from the collapse of a star, nor could it have simply eaten enough matter over the age of the universe to get that big. Astrophysicists theorize that leviathans like Phoenix a star might be primordial black holes formed not from dying stars but from the direct catastrophic collapse of massive dense regions of the universe, mere fractions of a second after the Big Bang itself. They have been there since the absolute beginning, silent swelling gods of the dark. Imagine for a moment finding yourself drifting in the vicinity of Phoenix a star. If you were placed just outside its event horizon, the experience would be completely counterintuitive to everything you've been taught. about the violent nature of black holes. With smaller stellar mass black holes, the gravitational gradient is brutal. The difference in gravity between your feet and your head is so extreme, it would tear you apart long before you cross the threshold. But with a leviathan like Phoenix a star, the event horizon is so unimaginably vast, so gently curved over hundreds of billions of miles, that the gravitational pull at the boundary is incredibly uniform. You would not feel any immediate pain. You would not feel the tidal forces pulling your body apart. In fact, you might not even realize you were crossing the point of no return. You would simply look out into the void and see a wall of absolute impenetrable blackness, covering half of the entire universe, blotting out the light of billions of galaxies. You would drift silently, peacefully, and completely unknowingly across the threshold, becoming permanently disconnected from the rest of reality. You would be swallowed by a shadow larger than our entire solar system, falling slowly toward a singularity that contains the mass of 100 billion suns. The existence of these leviathans forces us to confront a chilling philosophical reality. We often view the universe as a grand theatre designed for the eventual emergence of life, a cosmic stage where biology is the ultimate goal. But objects like TON 618 and Phoenix a star suggest a very different narrative. They hold more mass than entire galaxies. They dictate the orbital mechanics of trillions of celestial bodies. Their gravitational influence shapes the cosmic web itself. From the perspective of pure mass and energy, the universe is not a machine for creating life. It is a machine for creating black holes. Biology is just a fragile temporary byproduct, a fleeting chemical reaction happening in the safe, quiet suburbs of a cosmos ruled by invisible giants. We are the microscopic moss growing on the foundation of an unfathomable dark cathedral. And the sheer scale of these entities means that when they feed, they do not just consume matter, they consume the very concept of space itself, locking away 100 billion suns worth of potential behind an impenetrable curtain where the laws of thermodynamics, relativity, and quantum mechanics are held hostage. We look at these leviathans not just with scientific curiosity, but with a primal existential terror, knowing that they represent the ultimate unconquerable extreme of the physical world. But to cross that silent threshold, we must first survive the raging inferno that guards the gates. Black holes are famous for trapping light. I thought approaching one would mean flying into absolute darkness. But paradoxically, the darkest objects in reality create the most blindingly radiant lights in the universe. If you were to embark on a suicide mission, piloting a spacecraft directly toward an actively feeding supermassive black hole, your most immediate threat would not be the crushing gravity of the singularity. Long before you ever reached the shadowy boundary of no return, you would have to navigate through the most violent incandescent hellscape in the cosmos. You would have to cross the accretion disk. It is the glowing tombstone of billions of shredded stars, a funeral pyre burning so brightly it can be seen from the other side of the observable universe. To understand why a completely black object is surrounded by such blinding radiance, we must look at the mechanics of a cosmic slaughter. When a giant cloud of interstellar gas or an unfortunate star wanders too close to the gravitational well of a supermassive black hole, it does not simply drop straight down like a stone falling into a well. Because everything in the universe is moving and rotating, the doomed matter approaches on an angle. As the immense gravity seizes the star, it stretches and completely shreds it apart in a process called a tidal disruption event. The stellar remains are violently whipped around the black hole, forced into a rapidly tightening spiral. Because of the conservation of angular momentum, this chaotic debris flattens out into a massive rotating platter of gas and plasma, spinning furiously around the dark center. This is the accretion disk, but this disk is not a peaceful ring of floating dust. It is a terrifying engine of friction. As the matter spirals closer and closer to the black hole, it accelerates to relativistic speeds, moving at significant fractions of the speed of light. The inner rings of the disk are spinning much faster than the outer rings, causing the layers of gas to violently rub against one another. This unimaginable friction heats the gas to temperatures that defy comprehension. While the core of our Sun burns at a respectable 15 million degrees Celsius, the plasma in an active accretion disk can reach billions of degrees. The atoms are stripped of their electrons and the matter glows with an intensity that produces lethal doses of hard X-rays and gamma radiation. When a supermassive black hole is surrounded by a massive actively feeding accretion disk, the entire system is reclassified as a quasar. Quasars are the brightest continuous light sources in the known universe. A single quasar powered by a black hole no larger than our solar system can outshine its entire host galaxy of hundreds of billions of stars by a factor of 1,000. It is a beacon of death signaling the violent consumption of matter, and the destruction does not stay contained to the disk. The swirling superheated plasma generates magnetic fields of unfathomable strength. These magnetic field lines become twisted and tightly wound by the sheer rotational speed of the black hole, creating towering invisible magnetic funnels at the north and south poles. While the black hole consumes the majority of the matter, a fraction of the superheated plasma is violently redirected by these magnetic funnels and blasted out into deep space. These are the astrophysical jet's twin beams of plasma shooting outward at over 99%. The speed of light piercing through galaxies and stretching for millions of light years into the intergalactic void. It is the ultimate paradox of nature, the most efficient energy conversion engine in reality, a machine that converts mass into blinding radiant energy far better than nuclear fusion, is powered entirely by the ultimate destroyer of energy. But as you push your spacecraft through this blinding, raging storm of plasma, surviving the billions of degrees of heat and the lethal radiation, the blinding light suddenly stops. You reach the edge of the shadow. We imagine falling into a black hole as a sudden violent pull. I thought you would feel yourself being dragged to your doom, but crossing the event horizon is a silent, completely imperceptible trap. Let us assume, for the sake of this horrifying thought experiment, that your spacecraft possesses a magical shield capable of withstanding the billions of degrees of heat and the lethal radiation of the accretion disk. You have pushed through the blinding, swirling storm of plasma, and you find yourself floating in the eerie calm just outside the central shadow. You are now face to face with the event horizon. In popular culture, this boundary is often depicted as a physical waterfall in space, a roaring, turbulent edge where matter violently cascades downward. But reality is far more insidious. The event horizon is not a physical surface. It is a mathematical boundary, an invisible line drawn in the fabric of space and time. It marks the precise threshold where the escape velocity required to pull away from the black hole's gravitational grip exceeds the speed of light, because absolutely nothing in the universe, not even the massless photons of light, can travel faster than 186,000 miles per second. Nothing that crosses this line can ever return. If you are falling toward the supermassive black hole Phoenix, a star, your crossing of the event horizon would be the most anticlimactic, terrifying event of your life. Because the black hole is so unfathomably massive, the gravitational gradient at the boundary is incredibly gentle. You would not feel a sudden jolt. Your ship would not suddenly shudder or groan under the strain. If you had your eyes closed, you would not even know that you had crossed the point of no return. You would simply glide silently across the invisible line, permanently severing your connection to the outside universe. But the moment you open your eyes, the horror of your situation would become mathematically absolute. Once inside the event horizon, every possible path you can take, every direction you can point your spacecraft leads directly inward toward the singularity. In normal space, you have the freedom to move up, down, left, right, forward, or backward. But inside the black hole, the geometry of space-time is so violently warped that the concept of outward ceases to exist. Imagine trying to drive a car up a hill that is infinitely steep. It does not matter how powerful your engine is. You're going to slide backward, inside the event horizon. Space-time is falling inward faster than the speed of light. Even if you fired your magical thrusters at maximum capacity, pointing your nose directly away from the center, you would still be moving closer to your doom. Your struggle is completely irrelevant. You are no longer navigating through space. You're being carried by it. The event horizon is the ultimate silent trap. It does not kill you immediately. It simply guarantees that your death is an inescapable mathematical certainty. But while your crossing is silent and peaceful from your perspective, the universe outside is experiencing a profoundly different reality. This brings us to the bizarre mind-bending consequences of Albert Einstein's theories of relativity. I thought if I watched my friend fall into a black hole, I would see them disappear into the dark. But the universe is far crueler. You would not see them die. You would watch them freeze in time forever. To understand this temporal nightmare, we must shift our perspective. Imagine that you are not the one falling. Instead, you are safely stationed on a space station orbiting far outside the black hole's immediate gravitational influence, watching a robotic probe fall toward the event horizon. According to the general theory of relativity, gravity is not just a force that pulls objects, it is the curvature of space-time itself. Massive objects warp the fabric of reality, and this warping affects the flow of time. The stronger the gravitational field, the slower time passes relative to an observer in a weaker gravitational field. This phenomenon is known as gravitational time dilation. As you watch your probe descend toward the supermassive black hole, it enters deeper and deeper into the gravitational well. From the perspective of the probe's internal computer, everything seems completely normal. Its clock ticks at the usual rate, but from your safe vantage point on the space station, you notice something deeply disturbing. The probe appears to be slowing down. The closer it gets to the event horizon, the slower it moves. As it approaches the critical boundary, its downward progress seems to grind to an agonizing halt. It is like watching a video in extreme slow motion. Simultaneously, you notice a change in the light being emitted by the probe. As the photons of light struggle to climb out of the immense gravitational well to reach your telescope, they lose energy. In physics, a loss of energy for light translates to a stretching of its wavelength. This is called gravitational redshift. The visible light from the probe shifts from blue to green to yellow to red. As it gets closer to the event horizon, the light stretches further into the invisible infrared spectrum, then down to microwaves, and finally into the ultra-low frequencies of radio waves. From your perspective on the outside, the probe never actually crosses the event horizon. It simply slows down infinitely, its image becoming increasingly red, dimmer and fainter, until it completely fades into the blackness. The time dilation is so extreme at the boundary that relative to your clock on the space station, it would take an eternity for the probe to cross the line. The final image of the probe, frozen in time at the edge of the abyss, is plastered onto the surface of the event horizon, like a ghostly fading photograph. If you were watching a friend fall, you would be condemned to watch their frozen, fading image for the rest of your life, never knowing the exact moment they crossed the line and met their fate. The black hole creates an impenetrable wall of time, separating the observer from the observed, leaving only a fading phantom in its wake. Einstein's theory promises a smooth, painless crossing of the horizon. I thought relativity had the final say, but quantum mechanics violently disagrees, suggesting a wall of blinding radiation waiting to incinerate you. For nearly a century, Albert Einstein's general theory of relativity has been the undisputed king of macroscopic physics. It has successfully predicted the bending of starlight, the existence of black holes, and the gravitational waves rippling through space-time. According to this magnificent theory, the event horizon is not a physical brick wall. It is merely a mathematical coordinate. One of the core pillars of relativity is the equivalence principle, which dictates that if you are in freefall in a gravitational field, you should not feel anything unusual. You should not be able to tell the difference between floating in deep space and falling toward a black hole. Physicists refer to this peaceful crossing as the no-drama scenario. If you were falling into Phoenix a star, your crossing would be perfectly smooth, dark, and utterly uneventful. But this comforting assumption was violently shattered by a thought experiment that pitted the two greatest theories in human history against each other in a fight to the death. While relativity rules the massive objects of the cosmos, quantum mechanics governs the microscopic realm of atoms and subatomic particles, and quantum mechanics is notoriously unforgiving when its rules are violated. In the 1970s, Stephen Hawking proved that black holes are not completely black because of the boiling quantum vacuum of empty space. Pairs of entangled virtual particles are constantly popping into existence near the event horizon. Occasionally one particle falls into the black hole while its entangled partner escapes out into the universe. This escaping particle is known as Hawking radiation. Over unimaginable eons, this process causes the black hole to slowly evaporate. But this brilliant discovery created a terrifying paradox. Quantum mechanics has a strict rule known as the monogamy of entanglement. A particle can only be fully entangled with one other particle at a time. It cannot be in a polygamous quantum relationship. Here is where the nightmare begins. For the escaping Hawking particle to carry away the information of the black hole and prevent the violation of quantum laws, it must be entangled with all the radiation that was emitted before it. But at the exact same time, for the space across the event horizon to remain smooth and drama-free as Einstein demanded, the escaping particle must also be entangled with its partner that just fell inside. The particle is forced to choose. It cannot be entangled with the past radiation and its partner inside the black hole simultaneously. Something has to give. In 2012, a group of brilliant physicists published a paper that proposed a horrifying solution. To save the foundational laws of quantum mechanics, the entanglement between the particle escaping and the particle falling inside must be violently broken. In the quantum realm, breaking an entanglement bond is an act of extreme violence. It releases an immense amount of energy. Because this breaking is happening constantly to billions of particle pairs, every single fraction of a second exactly at the boundary of the event horizon, the released energy accumulates. It creates a literal firewall. It is an infinitely hot, microscopically thin shell of blinding radiation and blazing plasma waiting exactly at the point of no return. If this firewall exists, Einstein was wrong. The equivalence principle is broken. Falling into a black hole is not a smooth, painless journey into the dark. The moment the tip of your spacecraft touches the event horizon, it would be instantly vaporized by an impenetrable wall of high-energy radiation. You would be incinerated before you even had the chance to realize you had crossed the line. But if the firewall does not exist, then Einstein is right. The crossing is smooth, but the fundamental laws of quantum mechanics are broken, meaning our entire understanding of chemistry, atoms, and reality is fundamentally flawed. This is the firewall paradox. It is a war zone where physics is bleeding out and scientists are currently tearing their hair out trying to find a mathematical truce. But for the sake of our journey, let us assume Einstein wins. Let us assume the crossing is smooth, the firewall is an illusion, and you survive the transition. What happens next is a psychological horror far worse than burning alive. In our world, you can move freely through space, but are dragged helplessly forward through time. I thought this rule was absolute, but the moment you cross the event horizon, space and time violently swap their roles. To comprehend the reality inside a black hole, you have to completely abandon your human intuition. You have spent your entire life moving through 3 dimensions of space. You can walk left or right, climb up a ladder, or climb down, walk forward, or take a step backward. Space is a landscape you can navigate. Time, on the other hand, is a relentless one-way street. You are constantly moving forward from the past through the present and into the future. You cannot stop time, you cannot pause it, and you certainly cannot travel backward through it. You are a prisoner of the ticking clock, but the geometry of space-time inside the event horizon is so severely warped by the immense mass of the singularity that the mathematical signs actually flip. The dimension of space and the dimension of time swap places Before you crossed the boundary, the singularity was a physical location, a point in space located straight ahead of you. But once you cross the horizon, the singularity is no longer a place. It becomes a time. It becomes your inevitable future. Think about what that actually means. In the normal universe, can you avoid tomorrow? Can you steer your ship to dodge next Tuesday? Absolutely not. Time flows inevitably forward, carrying you toward the future regardless of what you do. Inside the black hole, the radial direction pointing toward the center becomes a temporal dimension. You are falling toward the singularity not because gravity is pulling you through space, but because the singularity is now your tomorrow. Every single second that ticks by on your watch brings you closer to the center. If you turn your spacecraft around and fire your engines at maximum thrust, trying to fly back out the way you came, you're not moving away from the center. You are just rushing toward your future faster. Trying to avoid the singularity inside a black hole is as impossible as trying to avoid aging. It is not a place you crash into. It is an event that happens to you. As you fall deeper into the abyss, the darkness around you is not empty. Because light from the outside universe is constantly pouring into the black hole alongside you, you would still be able to see the cosmos you left behind, but it would be horribly distorted. The light from billions of stars from galaxies colliding and from the cosmic microwave background is all bent and concentrated by the extreme gravity. If you look straight up away from the singularity, you would see the entire history of the outside universe playing out in fast forward, compressed into a tiny, blindingly bright halo of light. You are watching the death of the cosmos through a distorted peephole while you plunge toward your own inevitable execution. You are trapped in a one-way corridor of time and the clock is violently ticking down to zero. And as you approach the absolute end, the gravity prepares to pull off its most agonizing trick. I thought the crushing pressure of a black hole would instantly pancake you. But gravity inside has a much more agonizing execution method in mind. It prefers to pull you apart atom by atom. As you plunge deeper into the dark, one-way corridor of the black hole you are hurtling toward, the singularity, a destination that is no longer a physical place, but an unavoidable moment in your immediate future. If you had fallen into a small stellar mass black hole, a remnant of a single collapsed star, you would have already died a horrific death long before you even reached the event horizon. But because you're inside a supermassive leviathan like Phoenix a star, the initial crossing was peaceful. The true nightmare has been patiently waiting for you deep inside the abyss, lurking just outside the singularity. This nightmare is the absolute terrifying extreme of a phenomenon we experience every day on Earth. Tidal forces? On Earth, the gravitational pull of the moon is slightly stronger on the side of the planet facing it than on the side facing away. This tiny difference in gravitational attraction is enough to stretch our vast oceans, creating the daily rise and fall of the tides. Now take that gentle microscopic stretching and multiply it by 100 billion solar masses compressed into a microscopic point. As your spacecraft plummets toward the absolute center, the gradient of gravity becomes unimaginably steep. If you are falling feet first, the distance between your feet and the singularity is slightly less than the distance between your head and the singularity. In any normal environment, this minute difference in distance is completely irrelevant. But in the steep gravitational well near the core of a black hole, that tiny difference becomes a death sentence. The gravitational pull on your feet becomes exponentially stronger than the pull on your head. Your feet begin to accelerate downward faster than the rest of your body. You are subjected to an immense vertical stretching force. At the exact same time, because all paths in space are violently curving inward toward a single microscopic point, the left and right sides of your body are being crushed horizontally inward. You are being stretched lengthwise and squeezed widthwise simultaneously. Astrophysicists with a morbid sense of humor gave this horrifying process a cartoonish name, Spaghettification. But there is absolutely nothing funny about the physical reality of this execution. Let us slow down time and examine this macabre stretching step by terrifying step. First, the structural integrity of your spacecraft fails. The titanium hull groans, warps, and violently snaps, tearing into long, jagged ribbons of metal. You are exposed to the void. The tidal forces then assault your biology. The vertical stretching overcomes the tensile strength of human bone and muscle. Your spine violently separates. Your blood vessels snap, and the iron-rich blood is immediately stretched into thin crimson threads. Within a fraction of a second, your body is pulled into a continuous microscopic line of biological matter, miles long and thinner than a human hair. But gravity is not finished. It is far from finished. The tidal forces continue to escalate toward infinity. The stretching overcomes the electromagnetic force, the invisible glue that holds molecules together. The complex proteins, the water molecules, and the very DNA that defines your human blueprint are violently ripped apart into individual atoms. You are no longer biology, you are a stream of chemistry. But even the atoms cannot survive. As you get infinitesimally closer to the center, the tidal forces overpower the strong nuclear force. The electrons are stripped away and the atomic nuclei are cracked open, spilling protons and neutrons into the dark. Finally, even the subatomic particles are shredded into their fundamental quarks. You've been completely disassembled, reduced to a single file line of raw fundamental data streaming into the absolute dark. But where exactly is this data going? What is waiting at the end of the line? We rely on mathematics to decode the secrets of reality. I thought numbers could explain anything, but as we approach the core, the math doesn't just fail. It spits out infinity, declaring that our physics is officially broken. The stream of fundamental quarks that used to be your body, your ship, and the light from the outside universe all converge on the absolute center of the black hole. This is the singularity. To understand what the singularity is, we have to look at the equations of Albert Einstein's general theory of relativity. According to the math, when a massive star collapses, its gravity becomes so intense that no physical force in the universe can push back against it. The matter continues to crush inwards smaller and smaller until it reaches a volume of absolute zero. Think about the formula for density. Density equals mass divided by volume. The singularity contains the mass of millions or billions of suns. But if the volume it occupies is exactly zero, then you are dividing a massive number by zero. If you ask a calculator to divide by zero, it gives you an error. When the universe divides by zero, the result is infinity. According to relativity, the singularity is a point of infinite density, infinite gravity, and infinite space-time curvature. It is a point where the fabric of reality is bent so severely that it literally punctures a hole in existence. But here is a terrifying secret that physicists rarely say out loud. Infinity is not a physical reality. In the realm of physics, whenever an equation produces an infinity, it is not a triumphant discovery. It is a giant glaring red flag. It is nature's way of telling us that our mathematical models are fundamentally wrong. It means that Einstein's magnificent theory of relativity, the framework that successfully predicted the expansion of the universe and the existence of the black hole itself, has finally reached the absolute limits of its programming. The math commits suicide. To understand a singularity, we cannot just use the physics of the massive, because the singularity is infinitesimally small, smaller than a single atom. We must also use the physics of the microscopic, quantum mechanics. But this is where the ultimate nightmare of modern science is realized. General relativity and quantum mechanics, the two towering pillars of human knowledge, violently hate each other. They speak completely different mathematical languages. Relativity describes a smooth, continuous, predictable fabric of space-time. Quantum mechanics describes a choppy, unpredictable, probabilistic world of jumping particles and boiling energy. For a century, we have kept them separated, using relativity for stars and quantum mechanics for atoms. But at the singularity of a black hole, a massive amount of gravity is crammed into a quantum space. You are forced to use both theories at the exact same time, and when you try to merge their equations to calculate what happens at the singularity, the math explodes into absolute nonsense. The equations yield probabilities greater than 100%, which is physically impossible. The black hole does not just murder matter, it murders physics. The singularity is a veil of absolute ignorance, a cosmic censor that hides the breakdown of our universe from the rest of reality. We literally do not possess the scientific language, the mathematics, or the conceptual framework to describe what actually happens at the exact center. It is a place where the rules of cause and effect are erased. It is a glitch in the simulation of reality, but the destruction of your body and the breakdown of mathematics are only the prelude to a much deeper existential terror. Because while your physical form has been shredded, your information still exists. And the black hole is about to do something to that information that threatens to unravel the entire universe. If you burn a book, its physical form is gone, but the quantum information of its ashes remains. I thought information could never be truly destroyed until Stephen Hawking proved black holes might be deleting reality itself. To comprehend the magnitude of this intellectual catastrophe, we must first understand a fundamental unbreakable law of the universe that you rarely hear about. It is the principle of quantum determinism, or the conservation of information. In our everyday experience, things are easily destroyed. You can shatter a glass, burn a photograph, or crush a computer hard drive. But from the perspective of quantum mechanics, the fundamental data that makes up those objects is never lost. If you burn an encyclopedia, the paper and ink turn into smoke, heat, and ash. To human eyes, the words are gone forever. But if you possessed a theoretical supercomputer capable of tracking the exact trajectory, spin, and state of every single atom of smoke, every photon of light, and every speck of ash that floated away from the fire, you could run the laws of physics in reverse. You could perfectly reconstruct the encyclopedia and read every single word. The universe never forgets. It always keeps a perfect ledger of every particle and every interaction. Because if information can be truly lost, it means the past is unrecoverable and the future is completely unpredictable. It means the very foundation of science, the ability to calculate cause and effect, is a lie. For a long time, physicists believed black holes were the ultimate cosmic vaults. Whatever fell inside, whether it was a dead star, a doomed astronaut, or an encyclopedia, took its quantum information with it. The information was safely locked away behind the event horizon, permanently removed from the observable universe, but still physically existing somewhere deep inside the singularity. The ledger of the universe was balanced. But in 1974, the brilliant physicist Stephen Hawking dropped a mathematical bomb that shook the scientific community to its core. He applied the rules of quantum mechanics to the event horizon and made a terrifying discovery. Black holes are not completely black. They glow. As we discussed earlier, the vacuum of space is a boiling cauldron of virtual particles popping into existence in entangled pairs. When this happens exactly on the razor-thin boundary of the event horizon, the intense gravity can pull one particle into the abyss, while giving the other particle just enough energy to escape into the cosmos. This escaping particle is known as Hawking radiation, but energy cannot be created from nothing. To produce this radiation, the black hole must sacrifice a minuscule amount of its own mass. The black hole is literally evaporating. It is an excruciatingly slow process. A supermassive black hole like Phoenix, a star, will take an unfathomable amount of time to evaporate, a number of years, represented by a 1 followed by 100 zeros, an era known as a googol. But the time frame does not matter. The mathematical consequence is absolute. Eventually, the black hole will completely boil away, shrinking down to nothing and disappearing from reality entirely. And here is where the universe breaks. When the black hole evaporates and vanishes, what happens to the quantum information of the billions of stars, the planets, and the civilizations it swallowed over its lifetime? According to Hawking calculations, the radiation leaking out of the black hole is completely random thermal noise. It is like the static on a broken television. It contains absolutely zero information about what originally fell inside. The radiation emitted by a black hole that swallowed a billion encyclopedias is mathematically identical to the radiation emitted by a black hole that swallowed 1 billion tons of rocks. If the black hole disappears completely and the Hawking radiation carries no data, then the information of those stars, those planets, and your shredded body is permanently, irrevocably deleted from the cosmos. The ledger is destroyed. This is the black hole information paradox. It is not just a quirky puzzle for mathematicians. It is an existential threat to everything we know. If Stephen Hawking was right and black holes truly delete information, then the fundamental laws of quantum mechanics are completely wrong. Reality is not deterministic. The universe is actively erasing its own history, suffering from cosmic amnesia. For decades, a fierce intellectual war raged among the greatest minds on Earth. Theoretical physicists were thrown into a state of panic, desperately trying to find a mathematical loophole to save quantum mechanics from the destructive power of the abyss. They needed to find a way to rescue your data from the singularity before the black hole evaporated, and the solution they eventually proposed was so bizarre, so profoundly alien, that it completely redefined the nature of reality itself. We perceive the universe as a vast three-dimensional space. I thought depth and volume were fundamental realities, but black holes suggest that everything you are, your three-dimensional life, might just be a two-dimensional hologram projected from the edge. The desperate rescue mission to save the laws of physics was led by theoretical physicists Leonard Susskind and Gerard 't Hooft. They refused to accept Hawking's conclusion that information was permanently deleted. They realized that the key to solving the paradox was not hiding deep inside the crushing darkness of the singularity, but rather on the invisible surface of the trap itself, the event horizon. They looked back at the work of Jacob Bekenstein, who had discovered that the amount of information a black hole can hold is not determined by its three-dimensional volume, but strictly by the two-dimensional surface area of its event horizon. Imagine the event horizon not as a smooth mathematical line, but as a spherical screen made of microscopic pixels. These pixels are incredibly tiny, scaling down to the Planck length, the absolute smallest unit of measurement in physics. Bekenstein proved that you can only fit exactly one bit of quantum information into one of these microscopic Planck areas. The event horizon is a finite hard drive. Susskind and 't Hooft proposed a mind-bending mechanism. As your spacecraft, your body, and your fundamental quarks cross the event horizon, you do not just fall cleanly into the dark. Instead, the extreme physics of the boundary intercepts you. As you cross the threshold, your three-dimensional quantum information is perfectly extracted, smeared, and permanently encoded onto the two-dimensional pixels of the event horizon. Your physical form may continue to fall inward, marching toward your inevitable execution at the singularity, but the exact quantum recipe of what makes you who you are is left behind, painted onto the surface of the black hole like a microscopic barcode. You become a two-dimensional security sticker on the cosmic vault. Because your information is safely stored on the surface, it is no longer at risk of being destroyed by the singularity. And when the black hole slowly evaporates over a googol years, the escaping Hawking radiation interacts with this two-dimensional surface. The random thermal static picks up the encoded data, acting like a laser reading a CD, and carries your quantum information safely back out into the universe. The ledger is balanced. Information is conserved. Physics is saved from the brink of destruction. But the philosophical cost of this victory is staggering. This solution is known as the holographic principle. If the entire unimaginably complex three-dimensional interior of a black hole containing the crushed mass of 100 billion suns can be completely and perfectly described by the two-dimensional boundary surrounding it, it implies something terrifying about the nature of space itself. It means that the third dimension depth might not actually exist at a fundamental level. It might just be an emergent illusion, a mathematical trick played by nature. And if this holographic rule applies to the extreme environment of a black hole, physicists argue it must apply to the entire cosmos. Our universe has a boundary, the cosmic event horizon we discussed in the era of dark energy. What if the entire three-dimensional universe we experience, the towering galaxies, the deep oceans of Earth, the screen you're looking at and the brain inside your head are not truly three-dimensional objects? What if we are all just complex three-dimensional holographic projections generated by the interactions of quantum data encoded on a distant two-dimensional boundary at the absolute edge of the cosmos? Falling into a supermassive black hole does not just execute your body and murder the laws of relativity. It strips away the very illusion of your physical reality. It reveals that you are nothing more than a complex projection of mathematics, a ghost of quantum information clinging to the edge of the abyss. But even as a hologram, your journey is not over. The true center of the anomaly, the quantum singularity, is still waiting to reveal the deepest secret of creation. We imagine the singularity as a dot of infinite density. I thought it was the absolute end of the line, but zooming into the Planck scale reveals that the singularity might not be a point at all, but a violent storm of quantum foam. We have reached the final layer of the cosmic onion. Your physical body is gone, your 3D reality has been exposed as a holographic projection, and you're now face to face with the mathematical divide by zero error at the heart of the black hole. In the traditional smooth world of general relativity, the singularity is a geometric point where the curvature of spacetime becomes infinite. But we know this cannot be the whole truth. Nature abhors infinity. When we zoom in past the scale of atoms, past the scale of quarks, we reach the Planck length, a distance so small that the very concept of a smooth fabric of space breaks down. At this scale, space is no longer a continuous sheet. It is chaotic, boiling turbulence known as quantum foam. Imagine a calm ocean viewed from a high altitude. It looks perfectly smooth, but as you get closer, you see the waves, and if you get microscopic, you see the chaotic white spray and the bubbles popping. The singularity is likely a concentrated region of this quantum foam, where gravity and quantum mechanics are forced into a violent, permanent embrace. To solve the mystery of what truly happens here, we need a theory of quantum gravity. This is the holy grail of modern science. Theoretical physicists working on loop quantum gravity suggest that space itself is made of discrete loops, woven together like a cosmic chainmail. In this model, the singularity isn't a point of infinite density because the loops of space can only be squeezed so much before they push back with a repulsive force. Instead of a hole in reality, the center of a black hole might be a Planck star, an incredibly dense microscopic object that prevents the total collapse of physics. But there is another, even more mind-bending possibility, one that involves the rotation of the universe itself. I thought hitting the singularity meant crashing into a solid, inescapable wall, but the universe spins and its black holes spin too. Twisting that terrifying dot into a ring you might actually fall completely through. Every star and every galaxy we observe is in a state of rotation. When a massive spinning star collapses, it doesn't just create a static spherical black hole, it creates what physicists call a Kerr black hole, and in a Kerr black hole the math of the singularity changes fundamentally. Because of the conservation of angular momentum, the singularity cannot be a single stationary point. The sheer centrifugal force of the collapse flattens the singularity out, stretching it into a one-dimensional ring, the ring singularity. This is not a solid object. It is a ring-shaped fault in the geometry of space-time. In a stationary black hole, you're guaranteed to hit the center, but in a spinning Kerr black hole, the mathematics of the Einstein field equations suggests a terrifyingly beautiful possibility. If you approach the ring singularity from the side, the tidal forces might not destroy you instantly. Instead, you could pass right through the center of the ring. And because the ring is a puncture in the fabric of space-time, you wouldn't just be on the other side of the room. You would be somewhere else entirely. The ring acts as a gateway, a one-way portal that leads through a mathematical structure known as a wormhole or an Einstein-Rosen bridge. We are taught that nothing ever escapes the gravitational abyss. I thought the singularity was the absolute end of the journey, but mathematics offers a back door, a one-way exit into a brand new universe. If you were to survive the passage through the ring, singularity of Phoenix a star, you would find yourself exiting through the polar opposite of a black hole. You would be spat out of a white hole. A white hole is a theoretical region of space-time which cannot be entered from the outside, but from which matter and light can escape. It is a black hole running in reverse. While a black hole is an ultimate sink, a white hole is an ultimate source. This leads to the cosmic fecundity hypothesis, the idea that every black hole in our universe is the birth canal for a brand new baby universe. Our own Big Bang might have been the white hole exit of a black hole in a parent universe. We are part of a vast infinite tree of cosmic reproduction, where the crushing death of a star in one reality provides the explosive life for another. The singularity isn't a dead end, it's a transition. It is the moment where the old laws of physics are shredded to provide the raw chaotic energy for a new set of laws to be born. In our previous journey, we saw dark energy rip the stars apart, leaving an empty, cold void. I thought nothing could survive that, but long after the last star dies, the black hole will remain the undisputed kings of the dark. We have travelled to the absolute limits of space-time and human reason. We have seen the supermassive leviathans that anchor our galaxies survive the incandescent hell of the accretion disk, and crossed the silent threshold of the event horizon. We have witnessed the horn joy of space and time, the agonizing stretching of matter into single-file quarks, and the mathematical suicide of the singularity. But as we pull back from the ring, singularity, and the theoretical promise of white holes, we must confront the final longest chapter in the story of our universe. If we look into the far, far future past the death of the Sun, past the collision of the Milky Way and Andromeda, and past the era where dark energy has pushed every other galaxy beyond our reach, we enter the black hole era. In this distant epoch, the universe is a cold, dark and lonely place. Every star has long since exhausted its nuclear fuel, cooling into a black dwarf or collapsing into a stellar mass black hole. The only remaining sources of energy and gravity in the entire cosmos are the supermassive black holes. They will wander the void like silent, invisible ghosts for a duration of time that the human mind cannot possibly grasp. While a star might live for 10 billion years, a supermassive black hole like Phoenix a star will endure for a Google years. To visualize a Google, imagine every single atom in the observable universe. Now imagine each of those atoms is itself a universe containing another Google atoms. Even that does not come close. For almost the entirety of the universe's existence, black holes will be the only things that exist. They are the ultimate survivors, but even they are not immortal. Through the slow, relentless leak of Hawking radiation, these giants will eventually lose their mass. One by one, they will shrink, popping out of existence in a final microscopic flash of gamma radiation. When the last black hole evaporates, the universe will finally be truly empty. The era of matter and gravity will be over. The great silence will be absolute. We began this journey looking for monsters and we found them. But in studying these monsters, we discovered something profound about ourselves. We discovered that our reality is far more mysterious, fragile, and interconnected than we ever dared to imagine. We found that we might be holographic shadows of distant data, and that our deaths might be the seeds for new beginnings in other dimensions. The singularity is not just a place where physics breaks. It is a place where our current imagination ends and the next great discovery begins. We are a species that evolved on a tiny rock orbiting a mundane star, yet we have developed the mathematics to peer into the heart of a leviathan, a billion light years away. That in itself is the greatest paradox of all. We've travelled inside the darkest objects in reality, finding holographic prisons and pathways to other universes, but next part we're turning our gaze back to life itself. If the universe is this vast and billions of Earth-like planets exist, why is it so terrifyingly quiet? The great filter is coming, and you absolutely need to know if humanity has already passed it, or if our doom is right ahead. Subscribe now, you don't want to miss this. Imagine waking up in a massive dark mansion. You shout hello, but only silence answers. You search every room, billions of them stretching out into an infinite shadowy distance. You find grand hallways, ornate furniture, and vast libraries, but every chair is empty and every hearth is cold. This is not a nightmare. This is the current state of our existence within the Milky Way galaxy. For over a century, humanity has been screaming into the dark. We have broadcasted our radio waves, our television signals, and our very presence into the interstellar void, hoping for even the faintest whisper in return. Yet the stars remain terrifyingly quiet. The cosmos, once thought to be a crowded theatre of alien empires and celestial civilizations, has revealed itself to be a cosmic ghost town. I used to think the universe was a crowded stage waiting for us to join the cast. I thought the sheer number of stars guaranteed neighbours, but the more we look, the more it feels like we're the only survivors in a vast empty house. This is the heart of the Fermi paradox. In our galaxy alone, there are over 200 billion stars. In the observable universe, there are trillions of galaxies. Many of these stars are billions of years older than our Sun. If the laws of physics and chemistry are universal, then the recipe for life water, organic molecules and energy should be common. Statistically, the Milky Way should be teeming with life. There should be thousands, if not millions, of civilizations far more advanced than our own entities capable of building Dyson spheres to harvest the energy of entire stars or warping the fabric of space to travel between the suns. We should see their megastructures, we should hear their communications, but we see nothing. The great silence is not just a scientific mystery, it is an existential crisis. It forces us to ask, if the mansion is so big and so old, where is everybody? We often treat life like a natural consequence of physics, an inevitable byproduct of the right environment. I thought if you had water and heat you got a civilization. But when you look at the jagged, improbable timeline of Earth, you realize that life isn't a certainty. It's a 1 in a trillion accident. We live in a universe that is fundamentally hostile to the emergence of complexity. To get from a barren rock to a creature that can wander about the stars, you have to clear a series of astronomical hurdles. This is the rare Earth hypothesis. It suggests that our planet isn't just one of many, but a staggering exception. We are located in the Goldilocks zone of a stable, long-lived star. We are protected by the massive gravity of Jupiter, which acts as a cosmic vacuum cleaner, sucking up lethal asteroids before they can reset our evolution. We have a massive moon that stabilizes our axial tilt, preventing catastrophic climate swings. But the physical environment is only the first hurdle. The jump from simple single-celled organisms to complex multicellular life is perhaps the greatest biological miracle of all. For 2 billion years, nearly half the age of our planet life on Earth was nothing more than simple bacteria. It took a freak one-time accident where one cell swallowed another without digesting it to create the mitochondria, the engine of complexity. Without that singular event, Earth would still be a planet of slime. Intelligence, too, is not a guaranteed endpoint. Millions of species have existed on this planet for hundreds of millions of years without ever developing the capacity for mathematics or spaceflight. Dinosaurs ruled for 160 million years and never built a telescope. Evolution doesn't care about progress. It only cares about survival. We are a freak occurrence in a universe that prefers simplicity over complexity. Survival isn't a gift, it's a test. And the great filter is the ultimate examiner. It is a theoretical barrier so lethal, so impassable, that it wipes out nearly all life before it can ever leave its home planet. If the universe is a mansion of empty rooms, the great filter is the reason why. It is the cosmic sieve that prevents slime from becoming galactic empires. The terrifying question for humanity is, where is the filter located in our timeline? If the filter is behind us, if the hard part was the origin of life or the jump to complex cells, then we are the lucky ones. We have cleared the hurdle and the galaxy is ours for the taking. We are the first to wake up in the mansion. But what if the filter is ahead of us? What if every civilization reaches a point where its technology outpaces its wisdom? Perhaps the moment a species discovers how to harness the atom, it inevitably burns its world. Perhaps the moment it creates artificial intelligence, it is replaced by a cold, silent machine, Or perhaps the transition from a planetary species to an interstellar one is simply too energy intensive to be sustained. If the stars are silent because everyone who reached our level died shortly after, then our countdown has already begun. We are not the first, we are just the latest to walk toward the edge of the cliff. This brings us to a chilling realization about our search for life. We spend billions searching for a single microbe on Mars or a tiny fossil in the ice of Europa. I thought finding alien life would be the greatest discovery in history, but to a cosmologist, finding life on Mars would be the ultimate death warrant for humanity. As philosopher Nick Bostrom argues, if we find that life began independently twice in our own solar system, it means that life is incredibly easy to start. It means the origin of life is not the great filter. And if we find fossils of complex creatures on other worlds, it means the jump to complexity is not the filter either. The more common life is in the universe, the more likely it is that the great filter is waiting for us in the future. If the mansion is full of the corpses of simple life, it means the door out is locked from the outside. If we truly are the only ones, then we're not just a species, we're the only eyes the universe has ever opened. I thought our insignificance was a curse, a lonely speck in a cold, indifferent dark. But if the mansion is empty, then we are the masters of the house. We are the only part of the cosmos that can feel, that can love, and that can understand the laws of physics. If we fail, if we let our petty differences or our technological hubris extinguish this lonely speck, then the universe returns to a state of unobserved, meaningless darkness forever. The great silence is not an absence of sound. It is a weight of responsibility. We are the universe's only chance to know itself. Our loneliness is not a weakness. It is a call to action. We must be the ones who break the silence. We must be the civilization that makes it through the filter. We treat our presence on this planet as a given a solid foundation upon which we build our cathedrals and our empires. But when you look at the great silence through the lens of the rare earth hypothesis, you realize that humanity is standing on a pedestal made of 1 billion coincidences. I thought the universe was a factory for life, but it's actually a gauntlet of extinction. To understand why the mansion is empty, we have to look at the biological gauntlet, the series of near impossible jumps that we somehow cleared while countless others likely failed. Consider the timing. The universe is 13, 8 billion years old. Earth is 4, 5 billion years old. Life appeared relatively quickly, but it stayed as simple single-celled organisms for an eternity. For 2 billion years nothing happened. The world was a stagnant pond of bacteria. Then the impossible happened, the eukaryotic leap. This wasn't a slow evolution. It was a freak accident where one cell consumed another, and instead of digesting it, they formed a symbiotic bond. This created the mitochondria, the powerhouse that allowed cells to grow 1,000 times larger and infinitely more complex. If that one specific accidental merger hadn't occurred on a Tuesday 2 billion years ago, Earth would still be a planet of slime. There would be no trees, no animals, and no one to write Keach Ban about the stars. When we look at the silence of the galaxy, we are likely looking at billions of slime world's planets that started the race, but lacked the 1 in a trillion biological spark to move past the starting line. We spend billions of dollars sending rovers to the red planet. I thought finding a fossil on Mars would be the ultimate triumph of science. But to a philosopher of the great filter, finding life on Mars would be the worst news in human history. Think about why. If we find that life evolved independently on Mars, it means that starting life is easy. It means the origin of life is not the great filter. If we find complex fossils, it means the eukaryotic leap is not the filter either. Every piece of life we find out there eliminates a backwards filter. If the path from a rock to a human is easy and common, then the reason the galaxy is silent must be something that happens after our current stage. It means the filter is waiting for us. It means the wall is just a few centuries ahead. Finding a multicelled organism on Mars would suggest that humanity is statistically doomed to go extinct in the very near future. In the cosmic mansion, finding a neighbour in the next room who died of old age is a sign that the air in the house is toxic. If the mansion is truly empty, if we are the only lonely speck that has ever made it this far, it changes everything. I thought our insignificance was a curse, a reason to feel small and meaningless, but I was wrong. If we are the only eyes the universe has to see itself, then we are the most important thing in existence. We are currently approaching our own potential filter. We are playing with technologies that could end our story in an afternoon. We are the first generation with the power to destroy our world, but we are also the first generation with the potential to leave it. If we succumb to our tribalism, our greed, or our technological hubris, we aren't just killing a species, we're extinguishing the only light in 1 billion light years. We are the last candle in a dark infinite cathedral. The great silence isn't a mystery to be solved, it's a challenge to be met. We have to be the ones who survive. We have to be the ones who fill the empty rooms of the mansion with the sound of voices and the warmth of life. We are the universe's only chance to not be a silent cold machine.